So let's look at the electric fields practice sheet. The first part here, we're not really going to spend any real time on this. Filling the chart, I mean, those are all quantities you can find. Drawing the field lines, we've done stuff like this, and there's other places you can find that type of stuff in other videos and stuff. The big thing for that is symmetry, making sure there's field represented all around the objects is a really big thing for that type of thing. Finding charges and mass of nuclei and completing the chart for basic prefixes. Again, you can find that stuff in other places, and there's even videos on how to find charges and mass of the nuclei. We've practiced that before, and I've shown you some stuff on that before. So let's focus more on the actual questions on the second side. So the first one there, we're looking for the acceleration of a proton in a field of 14.6. Okay, well, it's a proton. You know the mass, you know the charge. That's pretty standard. So you've also got the electric field. So there's a couple ways you could do it, but you can start by just finding out what the force on it would be. You know, F equals QE. You know the charge. You know the electric field. You could find the force on the proton. And then, of course, once you have that, you know the mass of a proton is just a proton. So acceleration would just be the force divided by the mass. And that should give you the acceleration. It's number 6, that could kind of similar, except this time you got the acceleration, and this time you're going to try and find the E. For this one, you've got the electron, so you can do F equals ma. To get the force on the electron, you know the mass of the electron, that's a constant, gave you the acceleration. And then once you have the force, then electric field, of course, is force divided by Q, and you do know the Q of an electron. Right? And then you got to draw the E. Just be careful because it is a negative, so you got to be careful which way you are going to draw that electric field. Number 7, you've got something with a bunch of extra electrons on it. Okay, well, you can find out the Q value because you want to times that by the E value to tell you how many or how much charge is actually on it. And it is a negative charge. So you can multiply that number by the charge of the electron to get the overall, how many coulombs the actual charged object has. And then once you have that, it's going to be basic F equals QE to get the force. Just got to be careful again because technically it is a negative force because it is a negative charge, which means it's going to go against the field. And then number 8, you got an alpha particle, so it's a helium nucleus. So you got to find the charge and mass of the helium nucleus. We've done that type of thing before. It's between two plates that are 48 millimeters apart, starts at rest, and you've got the time to go across for the electric field. Okay, so a couple steps for this one. You got to, first of all, you got to find the charge, you got to find the mass. You'll need to find those for the nucleus. But if we actually look at the kinematic quantities, you've got a distance and you've got a time. So you can find the average V using distance and time. Just be careful with the prefixes. Of course, that's the average V. So once you have that, you know you can easily find the change in V. Once you got the change in V, pretty straightforward to get the acceleration. And then once you have acceleration, of course, acceleration leads to force. And then finally, you can find the electric field by taking the force and dividing it by the charge of the nucleus. Okay, so a few steps to that, but most of it's just basic kinematics and dynamics.